Hello everyone, and welcome back to another study shed video. Today we'll be going over the topic of solving second order homogeneous differential equations with constant coefficients. And what constant coefficients mean is we have a differential equation, we'll just write y prime plus ay prime plus by y prime plus cy equals 0. A, b, and c are numbers, not functions or anything. So that's what constant coefficients mean. And today we'll be going over the first of the three cases for solving with constant coefficients. And this is the function of case of real roots. So what does that mean? So you're going to have a differential equation. We'll call it y prime. We'll just keep it y, leading coefficient of 1 for now. Y prime plus by prime. Y double prime plus by prime plus cy is equal to 0. And so what second order differential equations have, or at least homogeneous ones, which means that this term over here is a 0. What that means is that what second order differential equations have is they have something called a characteristic equation, which basically, notice how this looks like a quadratic equation with double prime, prime, and y. Basically, we're going to write a quadratic equation, which is just normally use the equation r squared plus br plus c equals 0. And this is our characteristic equation. So in the first of three cases, so in case 1, this equation right here will have real roots, 2 real roots. So that's our first case. If you'd like to know, the second case is if this has 1 real root, and the third case is this has no real roots and 2 imaginary roots. So, first off, how would we go about solving such a second order differential equation? Well, the first step is to identify the general trend of solutions. Lucky for you, these solutions generally have a pattern, and we could derive it by just using inspection, but I'd rather not do it. It's a lot of work. If you're interested, we can do it in another video. But for now, what we need to know is the solution to this equation is equal to c1 times e to the r1 sub 1t plus c2 times e to the r2 sub 2t, where r1 and r2 are the roots of the characteristic equation, and c1 or c2 are constants, which we would solve for if we had a initial value or initial condition for this differential equation. So this is something you have to memorize, because unless you want to derive it each time, which it takes a long time, it's just something where you can solve the characteristic equation, plug in for r1 and r2, and then move about your way. So we'll do a practice problem right now. Alright, so our practice problem is going to be y double prime plus, here, let's do 5y prime plus 4 equals 0. 4y, not 4. So how will we do this? We'd start with the characteristic equation, r squared plus 5r plus 4 equals 0. We're now going to solve this for r1 and r2. We get r plus 1, r plus 4 equals 0. We're getting r1 equals negative 1, and r2 equals negative 4. And here is our r1 and r2. So now all we're going to do is we're going to replace them into our general formula, y equals c1 e to the r1 sub 1t plus c2 e to the r sub 2t. We're going to replace r1 and r2 with their appropriate numbers. Just put a negative sign here. Negative t and negative 4t. And we're done. This is our final solution, as this is a kind of general solution, as we don't know what c1 and c2 are, as we were not given any initial condition. So that is second order homogeneous differential equations with constant coefficients. This is the first of three cases. That's essentially how it works. In fact, I don't think there are any other weird cases in this scenario. So hopefully you learned something new today. If you did, feel free to leave the video a like. And as always, happy studying.